much for having me. I'm excited to be at LastCon for the first time and speaking here. It's also really convenient because I live here in New York and we have our office just north of here. So very nice, and I'm excited to be here and share how you can start and kind of give you a glimpse at monitoring, automating the real world with data from sensors and integrating that with Elastic and Viam. So yeah, a bit about me. I've been, even before joining Viam last year, I've been like a hardware tinkerer and hacker and home automation enthusiast, always trying to set up little smart scenes and things at home to a limit. And then I enjoy climbing and I enjoy cycling. And don't worry about that last part there. You can, if you want to find out more, just ask me later. So yeah, you all probably know we live in a world of connected devices. It's growing and growing more and every day. It's going from what was just our computers at home and maybe our printers to light bulbs and our phones to, cars and appliances and factories, and more is going online and has data there that's trying to be collected in some way. And it can be in all different sort of scenarios and environments that you'll find these sensors and this data. Can be at the very edge of our network in like rural farmlands or the depths of our oceans or even like the upper atmosphere of our planet. And then you can also find it, at your homegrown solutions that you may have already set up or started tinkering as well. And you also still want to be able to get that data and use it effectively. And so Viam is the engineering platform for gathering this data, applying to ML and AI, and be able to automate those physical devices and your software, and provides a nice, helpful interface for all of those solutions, whether you're going from your first robot to a fleet of machines across the world. And so I want to go over a real-world example that I've been working through for a good part of this year. So I do a lot of laundry. I work from home occasionally, and my office is in the basement right next to the laundry room. So that's my responsibility, is when I'm there, I do a few loads during that work day. And I have some older machines, so they don't always succeed when I start a load. They'll sometimes time out. I get some weird error code that pops up, and I never know why. It's just annoying when that happens. And sometimes it'll happen, I'll come back later and it didn't complete because I thought it was going to be like done like 30 minutes later. And it's like, all right, got to start that all over again. But also I just sometimes forget about them. And so I want to know when they're like running and when they've stopped. And if they have stopped, was there some weird event that led it to stopping, not when I expected to, not succeeding in that? And so being a dedicated VM developer, I looked for some hardware and some components, some sensor that would tell me, what kind of information do I need to track, something happening with my washers. And I know washers and dryers, they move a lot. So let's try to see, like, is something in that movement, is something being loaded in there affecting the movement oddly? Maybe it's getting the barrel of each device like out of sync and something's happening there. Or maybe even like the temperature of the room is affecting the hardware itself. And so in order to gather all those data points, I reached for this combo sensor, which is a MPU 6050, and we support it within VM platform along with many other sensors. And it provides all those data points. It gives me accelerometer data, gyroscope data, and temperature data, all with one component, meaning I don't have to, I could hook up many and start to gather on those, but just starting simply with this one was the easiest path for me to get started. And so I wired it up to a Raspberry Pi that I had lying around and, deployed it to my washing room, production. And the extra long jumper wires there are actually for, so I can have the Pi not on the machine while it's running, because vibrations in computers, they don't always work out in the long run. So it's better to kind of like just keep the sensor there, which is made for it, and have the computer somewhere else. And so I went through and set up my machine inside of Viam. This is kind of what the app interface looks like. I deployed Viam server to my device, and now I have it online and connected, and I can start configuring the various hardware components that I want to start getting data from. So to drill in there, we have this, what I'm calling the washer movement sensor. It's that gyroscope, the accelerometer, that combo sensor that I have. I configured it to say what the communication protocol I use is called I2C, and so I tell it what bus to listen on through the wiring that I did earlier, and then I can tell it to start capturing data from that sensor. And so every half a second, it will read from that sensor and then give me some data and then store it on the device. But now it's on the device. And so like, how do I get it so where I can use it? Well, we have a nice little data manager, which is a different service you can deploy to the device as well. And that allows you to start tell it when to capture data and then also when to sync that data to VM's data management portal. And so I can configure that across many machines, but I'm just starting with this one. And so I can turn off syncing temporarily and then, or if it goes off the network, data will still be captured and then it will sync when it get back on the network because even in White Plains, New York, the network isn't always the most solid and dependable, I'll say. And then I can even start previewing what those sensor data points look like before I even start capturing them or while they're capturing them in real time. And so this is also within the app. And then it allows me to start seeing every second, like what is the data I'm previewing and starting to get a good idea of what those values will look like. And as they start capturing that data, I can go look at what that looks like in the VM app. And so this is all the data as it's gathering, 30 times a minute, which might be overkill, but I don't know. I'm still trying to learn how often I need to gather this data. And then I can start to, again, look at these readings as they appear in our data management system. And so you can see we have this angular velocity that equates to our gyroscope. We have our linear acceleration for the accelerometer and our temperature, which is measured in Celsius. And now that I have that, I want to put it into a familiar interface for me to query it and start to do more with that. And so I can get data by connecting to VM app through some Python. And so this is a little bit of script for just using an API key for your VM organization in order to connect to it and then access a data client. And with that data client, we have this ability to create filters. So in that interface you may have that I was showing before, this was a filtered view of all the data I had within my organization. And so within here, we can see, okay, we have our location that the machine is located in, what the ID is, and all these certain things that will tell me like, all right, here's where to get the data from. And it's one way of querying for that data. So I can create a filter, say I'm looking for this component name, and start to get all that data and then do something with it. I wonder what it'll be. And so you can also query by using SQL or MQL because we store all this stuff in Mongo. And so if you're familiar with any of those, this might be a better interface for you to start like exploring the data or getting it from VM. But now, once I have it, I want to start pushing it up into Elasticsearch. And so using some handy code that I learned from Jessica, this is all you really need in order to take the sensor data I was querying from VM, and then I create an index with matching that sensor data's that sensor name, and I just start to upload it. And this doc generator method here just goes through that list of data I'm getting back from one of my queries, and then yields out. So it's a generator, as it says, and applies the actual like format needed to store this document inside of Elasticsearch. And so I'm setting the ID to be the time received, so I have a unique ID per data point. And then the source of that data, I'm going to include the various readings that you saw before, including that linear acceleration, the angular velocity, all that type of stuff, as well as the time received. So now I have a time series of data to go through. And so now I have this massive index of sensor data that's located in there. And we can, I don't know if I can zoom in here, but there's each of these documents. You can see that data point of when that data was received in VM, and now it's ingested into an index. And we can explore the various documents, all those mappings that are available, the types of data that they're available, like the floats, or if it's going to be a regular integer, whatever it's going to be. And now, once I have it in an index, I can now to visualize it. And so now I can set up a dashboard in using Kibana, and then I can start to explore this vibration movement. And this is really interesting to start seeing, like, okay, over per 5 minutes, these are these data points that I'm gathering, and they're kind of wild to see the accelerometer data, or this actually the gyroscope data, and seeing like, all right, what axis is having the most changes throughout a load, how much is really mattering, and these weird like positive and negatives. Like, what are these happening right now? I can start to explore the acceleration as well. There are not as many wild swings, but there's still some movement in there. So I can tell when it's running and when it's not running, which is key for me to be able to alert on something maybe later on, and be able to say, okay, something's done. Whether I succeed or not, that's for me to determine later, as well as the temperature within the room, which you can see it going up over time as I'm running loads, because the washer and the dryer are both running. You heat up a small laundry room that's located in. But now that was the data I was gathering during that one ingestion point. But now if I want to gather data in real time, if I want to be able to keep getting data and keep updating my index, we have ETL. So we're going to extract data from VM. We're not going to do much transformation. Then we're going to load it back into our Elasticsearch index. And so rather than maybe doing something like a cron job and having like maybe every 5 minutes querying and then trying to upload, I want to be a little smarter than that, use my resources effectively. And so we have triggers within the VM app, so you can set something to say, okay, when new data has synced within it, which is also good when the part is offline. I'm not trying to query for new data all the time when there's nothing new. I can only, once it comes back online and new data is synced, I'll get a webhook notification to some cloud function to say, okay, now you can go and it will include the new data that's being synced and then add that to my index. And so it gives you all these sort of data points, but the key thing for me is that little data field that's included as part of the request, the webhook. And so it includes a whole lot of things for like what the organization is. And so you can be very smart about, okay, if I have various components also hitting the same web component or web hook, then they can go to the correct index based on that component name or however I decide to break up and name those things. And so that data field I can use now to basically take the same code I was doing before to take the data and then bulk upload up to the index. Pretty much the same. I just put it under if anyone's heard of the functions framework from Google and GCP. So I put it under a Google Cloud function, and now it's basically the same code. And this is all that's needed to now have real-time updates going into my index. And then I can configure my trigger here to use that webhook and make sure that it's pinged, once a minute, or often, or even less. And so now whenever Typo sensor is synced, I get a nice little notification to my webhook. And that looks a little bit like this. So now you can see this is going at 20x speed, by the way, because it's only syncing once a minute. So I'm not going to make you sit through 8 minutes of just going through it. But you can see it updating over time. This is showing data received every per 30-second blocks here. And so you can see it kind of updating over real time. And now this is a live updating dashboard for me for all the data coming through from my laundry room. But you can extrapolate and make it a bit more professional at that. And so now as we dig again into this data and start to really analyze and see, all right, what are some weird, maybe like manually anomaly detection sort of thing going on. And so I can look and like this weird swing downward seems very odd. And so maybe I want to set up some sort of alert based on like, okay, if it's gone past like -1, or even getting past -2, it's like that seems like an odd behavior to happen while something's running. So I can use a rule within Elastic in order to set up, okay, based on this threshold, we're going to look down here from my data view. I'm going to say if it's below -1, then tell me about it. Let me know. And so you have a lot of actions to choose from within there. But again, I'm really focused on these webhooks. I think they're very interesting. It allows you to connect services really easily. And there's some interesting stuff we can do with that webhook, like activating a physical device when something happens to alert me, rather than just getting an email or getting some sort of Slack notification. What if I just had a little light that showed me like, hey, something happened, it's done, what's going on now, that I can just have sitting in front of me when I'm distracted by music or whatever, and start to expand from there. And so I can set up my fun function as a webhook connector, and then start to maybe in real life, set up good authentication and all that type of stuff. For me, this is just for my home, and I can shut down that function anytime I want. But now I've set up a Google Cloud function that can do something with my device. So I can configure it to say, okay, when the status changes, it's reached that threshold and it's an alert happening. then I can get this various data that I've configured here as the body of that request. And it can tell me, okay, why did it go off? When did it go off specifically? And all that type of stuff. And so, as I mentioned, not only do we have APIs for connecting to VM data and our cloud services to be able to get stuff from there, we also connect straight to your devices using a variety of programming languages, including Python, Go, C++, TypeScript. We also have support for Node.js with our TypeScript SDK now, and even Flutter. So you can do all sorts of things to connect directly to machines and control them. And so this looks very familiar to what we were doing like before within connecting to VM client. Now we're connecting to our robots. We will intermix like robot and machine within VM docs. So just a heads up, like they're both the same thing. And we can use our API keys either for organization or specifically for a robot, depending on the scope we care about. And then the address for that robot is actually like the DNS request being we use WebRTC, but we need some way to connect the two devices first. That's called signaling. And so we can connect to that device and start to do something with it. And so using some of the APIs for our board components, so I can talk to the GPIO on a Raspberry Pi, which is our single board computer. I can start to blink an LED, which is like the hello world of hardware. If you've ever gone through a hardware tutorial, it's like, I'm just going to blink something really quick, and it's great. You see something light up, and it's so exciting. And so I'm just going to blink an LED for a few seconds, and that's going to tell me like something's going on when that alert gets triggered. And again, I'm going to shove this into a nice little function and deploy it to Google Cloud. And besides what was in that blink LED and that connect those methods, this is all that's needed. I get some data from my form. I can do something with it if I care about it. And then I can pass it to my blink and then have it run. Whew. All right. Let's hope the demo gods are with me today. I have my nice little thing here. Now, I'm not home in order to run a load and see what happens. So we're going to do our little we're going to test out our connector as a way to simulate something running. So I'm in Elastic right now, and we can go to our connector here. We can see it's hooked up with to my app, and then I can run a test. And so since my function doesn't really care much about the body of the data right now, I can still just say like, I can put whatever I want here right now. Hello world, and then it's gonna run, and hopefully we'll get a nice blinking LED right there. Hey! Thank goodness, I'm so glad. Bring your own router whenever you're going to stuff as well. Like I'm still going through like the Elastic stuff, but bring your own router. It makes things really easy. All right, back to presentation. And so where do you go from here? You have this way now of gathering data and be able to affect the physical world. Like it doesn't have to just be blinking LED. It can be moving a motor. We actually have a setup in our like big all hands space within the VM office where someone had made a Zoom raise your hand bot actually. So it's a little like 3D printed on a servo thing. So when someone raises their hand in Zoom, it just raises it there. So it always gets noticed rather than getting like if the screen's behind them, they never notice when someone raises their hand. So it's a physical thing. If someone doesn't answer a question soon enough, it'll start waving itself and everything too. So you can start to interact more with physical devices by using like the standard, sort of software that you're used to. You can integrate it with Python. You can integrate with a mobile app, with a TypeScript app. If you want to see any of the code in full detail for this, I have it up on my GitHub. It's just called, I'm at Hipster Brown. It's physical world monitoring. You can go visit the VM docs. We have code labs that are self-paced tutorials that you can go through. And of course, this very helpful article by Jessica that really helped me figure out how to go through all this and integrate it with Elastic. And then, oh, come on. Okay. We have our Discord if you want to join that for any developers who want to start tinkering and asking questions. You can find me on LinkedIn. Like I said, I'm Hipster Brown on socials. We have I don't know why that would show up, a little QR code if anyone wants to sign up for the app right now or just be interested in creating accounts. And if you have any other questions for me, let me know. I'm over here. We have some cookbooks with recipes of how to build your own projects at home. We have some stickers with a fun cat and robot arm and everything. And then also If we have some time, we can drive around this little guy who's also connected and can be controlled from my phone or a web browser, and has a little camera, some motors, a bunch of other stuff on it. And that's my little travel rover that we have to show off a bit more than just blinking an LED. But I didn't dare drive it around during this conference. So thank you very much. Take
Questions? Any questions? Does anyone want to?
Have you considered productizing your vibration collection data? Because you can track, for example, moment when machine is going to break.
Yeah.
If you utilizing elastic machine learning to detect and prevent this moment, plug it out before.
Yeah, I want to try to start working with some anomaly detection models, like some ML models. I was actually exploring some of that within Elastic, and I haven't fully fleshed it out enough and got enough data to really prove out any anomalies. I haven't run enough loads yet, but I want to keep exploring those aspects of it before like productionizing it, make it a little bit smarter than just a simple threshold, because there's so many machines out in the world and gathering that. And another thing I want to try collecting on is like all these machines sing now, so I want to start using audio data as well as a signal for when something goes wrong or something happens. And so that's another sort of aspect of data that you can start gathering and working with. But right now it's a fun home project, and it'll be a while until I productionize it and maybe try deploying it into my parents' house or wherever else. So.
Any other questions?
So like several of the use cases you've shown, the volume of our data could be quite high, like, and also the velocity, especially let's say if you're doing some field monitoring and moisture of some fields or something, right? So how do you, what would you do for scaling something like this? Like would you ingest directly into Elasticsearch, or would you have a middleware? Like, what would you do and what kind of triggers?
So scaling what part of it specifically again?
Handling the high velocity stream of data from multiple sensors across multiple areas.
Yeah, so what we have within VM, if you want to have the same machine like replicated many times, basically, and we have things called fragments, which allow you to update the configuration across many machines at once. That's helpful for sharing common configurations. Another aspect of it is if you have something that's kind of nice about the serverless approach of having a webhook for signaling when you have new data, means it can scale up and down as much as you need to. So if you have many machines that are syncing data at all times, and then you can start pushing that and queuing it, however you want to handle pushing new data over to Elastic Index. I haven't pushed the bounds of like what bulk uploads look like within Elastic yet, but I imagine it probably scale up pretty well too, depending on like how you have it configured and deployed. And so you can, I mean, starting simply and starting to add more and more machines, even VM will start to scale up as well as you start to, the way we store data is efficient. So you're not paying a bunch out while we're storing it and while you're also ingesting it into Elasticsearch. And so that's part of the reason why we use Mongo in the back end, because we can keep scaling that out and using their Atlas service for that sort of thing.
And the trigger wise, is it a momentary triggers, or is it can also be temporal based, like, over a period something happens kind of triggers?
Yeah, exactly. So you can configure. We also have triggers for things like certain conditions and data. You can also create custom sensors that can allow you to do a bit smarter with certain things, like integrating ML models as part of your trigger as well. So if it sees a certain person, or if you want to do some CV type of thing, or if you want to do, again, anomaly detection in order to trigger certain data, you can start to configure that sort of thing too.
Thanks.
Yeah, thank you.
We have one more minute, but if there's any last questions, we can do that. And then I kind of want to see this robot go around. So,
Hey, how much time would you estimate that VM software saved you when developing this project?
Oh my gosh. Well, first of all, I didn't have to create the sensor driver myself, which is saving me hours at least on that side of things. Like I've worked on embedded devices before within like Raspberry Pis and on like microcontrollers. And so like I've spent that time before to do it, and it's great to not have to do that, as well as not worrying about how to deploy the code and keep updating it over time. Like, yes, it's on my local network, and I can probably SSH in and do stuff but also I can just push this out on like an LTE network somewhere there and still have the same user experience. So like, it's been really helpful to have that familiarity within my local development as well as like my remote stuff. So it saved me, I would say, like a weekend project became an actual weekend project versus it being like, okay, I got a sensor running now in a weekend. Now what else do I do with it? And actually configuring all the stuff with like ingesting and getting all those alerts set up took me about a day to do actually, just to learn a bit about the Elastic platform or enough to like ingest stuff and work with it. And then the easy part for me was actually just because I'm familiar with the VM platform, just capturing the data and then just learning how to like move it somewhere else. So like there's still a learning curve with any sort of hardware. And also I didn't have to worry too much about like learning how to wire certain things up. I'm familiar with that. But otherwise, once you get the basics underway, I don't have to worry about power because it's USB to the wall. There's a lot of stuff that makes it fairly easy, or I should say approachable to getting started with. All right, let's see if I can drive this thing around
Cool.
on our local network.
And thanks everybody for hanging out today. Thanks to Nick. That was incredible.
Thank you all.
Yeah, thanks.